Hi everyone, we're on chapter 5 now, and this is the last chapter that you'll be learning for this semester. And this is section 5.1 about exponents. When you're identifying your base, you have to pay close attention. Does it have parentheses or not parentheses? Because that's going to determine what kind of sign it might have when it's negative. And so it says that for each of the expressions, state the exponent shown and its corresponding base. All right, so the exponent on this first one is 6, right? Exponent 6. And our base is -3. Okay. On the next one, our exponent is 4, right? Because it's 3 to the 4th power, and that means the base is actually 3. On the next one, because it kind of shows one up here similar to this, notice that I do know my exponent is 6, but my base this time is 3 because this was not in parentheses, so the negative in front of the 3 is not part of the base. And on the next one, my exponent is 2, and my base is 5x. And the last one, exponent of 2, because it's x to the second, and my base is only x because that means 5 times x to the second, and so we don't have to talk about that base there. So when it's just to the first power, we don't really have to include that. All right, next. Now it says to evaluate. So when I evaluate this first one, this means -1 times 3 squared. So that's going to be -1 times 9, which is -9. So without parentheses, this is a negative. With parentheses on the next one, this means -3 times -3, and it is a +9 because there were parentheses. Now on the next one, it doesn't really matter when it's a cube. This means -4. Right, this means -4 cubed, right? And so the 4 is the base, but on this one it is negative, and it would have been negative regardless of how we wrote that. On the last one, it's also negative, right? -4 times -4 times -4, which is -64. So you see, whenever we have an odd exponent, it kind of turns out the same, but with even exponents, it will be different depending on where the parentheses are placed. Okay, this next one says take -4 times 3 to the 3rd power. Well, 3 to the 3rd power is 27. And you guys, if you're not sure how to use your exponent key, you may have to find it on your calculator. For some calculators, it will look like this, and you put in the base, push that, and then the exponent. Some calculators might have a y to the x, and then some calculators are going to have x with a little box up here. Well, I think they actually give you a box for both. So they give you a box for the x and a box for, right, because your x is going to be some number, and then you put your exponent in the box. So if you're not sure how to use that, you may want to just look it up online or something, because it may, you can't really do this. Well, I guess you can. You can just enter it without the exponent key. All right, so this one is going to be -4 times 27, I believe is -108. Right, 4 times 27. I'm double checking myself. All right, the next one means -1/9 times -1/9, and that leaves me with 1/81. All right, so it is still a fraction. The next one is just 9 times 1, because it doesn't matter what exponent we put on the 1, it still will equal 1, so that is 9. Okay. Next, evaluate each expression for the replacement values given. So we're kind of doing the same thing, but we have to put in the replacements. All right, so it's x squared and y to the 3rd, and x is 2, y is -1. So -4 times 4 times, I'm going to put parentheses on that since it's negative 1, because negative 1 to the third power is still negative 1, because it's to an odd power, negative 1 times negative 1 times negative 1. And then lastly, we're going to go ahead and multiply this, and we end up with a positive 16, right? Negative 4 times 4 is negative 16. Negative 16 times negative 1 is positive 16. Okay. Whoops. Get back here. So I have 10 over 3 times y to the third. In this case, y is 5. So then we have 10 over 3 times 125. That's what 5 to the third power is. And so then we have 10 over 375. I'm going to check myself on that. Oops. We could have simplified it some there. Maybe let's go ahead and do that. So let's take a 5 out of this, so that's 2. And a 5 out of 125 is going to be 25. All right. So now we have 2 over 75, 3 times 25. Maybe I think it's easier to just go ahead and simplify it since we had it in that form, and then we don't have to have such big numbers. Okay, so this is called the product rule for exponents, and it's basically saying if we're multiplying the same base, we add the exponents on that base. So we treat numbers like we always have. And so on this first one, this means y to the second times y to the first. So that's just y to the third. On the second one, I have negative 2 times negative 2, so that's 4. Z to the third times z to the second is going to be 3 plus 2 on the z's. So it's 4z to the fifth. On the next one, we're just going to add exponents on the a's. So we have a to the 2 plus 13. We have b to the 1 plus 17. So it's a to the 15th times b to the 18th. And we're done with that one. So it says use the product rule to simplify each expression. Write the results using exponents. So that means on some of these, we're going to just leave the number there. So on the first one, we have negative 5 as our base. So it's going to be negative 5 to the 7 plus 6. So 7 plus 6 is 13. And we're just going to leave that because that would be a huge number. And it says write the results using exponents. On the next one, maybe we need to write that as 7 to the second. So negative 7 squared. We're going to add the exponents on the a's. So that's 3 and 19, which is 22. On the b's, we're going to have 3 plus 1, so that's 4. Now, I think you could leave this one with the negative 7, or you could write it as negative 49 as far as I'm concerned. Pay attention to the directions on my math lab so you don't mess that up. All right, on the last one, we just have to leave the 12 because we can't write that with exponents. So it's going to be 12. And then we're multiplying 12 by a negative 1, so it'll be a negative 12. On the x's, we have 3 things. We have 5 plus 6 plus 4, and that equals 15. And notice I just applied the negative to the 12, and that's all we have to do with that one. Okay, I think we'll stop right here and take this up on the next video.